Good morning, ladies and gentlemen. How are you going? Hope you're doing okay. Today we're going to look at exercise 5G and 5H, which covers a volume and capacity. So we would have talked about this in year 8 before, so it's a bit of a recap. So for starters, let's start with volume. So volume is the amount of space taken up by an object. We measure volume in cubic units, so millimeters cubed, centimeters cubed, meters cubed, and kilometers cubed. So if you remember back in primary school when you played around with these little wooden blocks, right, these little wooden cubes, the idea of volume is how many of these little cubes can you fit into the rectangular box. That's the volume of the box. So we're looking at cubic measurements, cubic units. How do I get rid of that? Get rid of that. Let's shrink that down. So now that we understand volume is cubic units, is the amount of space that occupies an object. How do we convert the units? Well, let's start by arranging our units from smallest to biggest. So millimeters cubed, centimeters cubed, meters cubed, and kilometers cubed. Arrow up to the right, arrow up to the right, arrow down on the left. D comes before M in the alphabet, so divide on top, multiply on bottom, divide on top, multiply on bottom, divide on top, multiply on the bottom. Now, there are 10 millimeters in a centimeter, so on the top it's 10, but because we are cubing all the units, we need to 10 cubed is what we're dividing by and multiplying by 10 cubed. From centimeters cubed to meters cubed, there's 100 centimeters in a meter, and then we're cubing all the units, so it's 100 cubed. And similarly, there are 1,000 meters in a kilometer, but because a volume is all about cubic units, we have to multiply and divide by 1,000 cubed. So volume is the amount of space which an object can occupy. Well, what is the difference with capacity then? Well, capacity is the amount of liquid or gas a container can hold. We measure capacity with milliliters, liters, kiloliters, so capital KL, so KL for kiloliters, and capital ML for megaliters. So milliliters is lowercase m, megaliters is capital M, so be careful of that. So if you think about a capacity, it's when you're trying to fill up a water bottle and you're trying to see how much water or how much liquid can be poured inside this water bottle. So volume is the amount of little cubes you can put inside the container, whereas capacity is the amount of liquid or gas which your container can hold. So essentially they're both kind of talking about how much stuff can be inside the boxes of interest, but volume is cubic units in cubes, whereas capacity, it's what we usually measure liquids in, so liters, milliliters, or megaliters if you're measuring the amount of capacity of or water in the Olympic pools. To convert units in capacity, again, start off with your smaller units, so milliliters, lowercase l, then capital L for liters, capital KL for kiloliters, and capital ML for megaliters. Up arrow to the right, down arrow to the left. D comes before M in the alphabet, so divide on top, multiply on bottom, divide on top, multiply on bottom. Now, capacity is easy because you are literally multiplying and dividing everything by 1,000. Not squared, not cubed, just 1,000. So that's pretty much it. Now, the question is, how do we connect volume and capacity? Well, there's two important formulas. Formula number one, relationship number one, is 1 centimeter cubed is equal to 1 milliliter. The other relationship is 1 meter cubed is 1,000 liters, or you can say that 1 meter cubed is 1 kiloliter, since there's 1,000 liters in a kiloliter. So if we want to convert between volume and capacity, we can use these two important formulas. Now, what is the default formula for volume? So volume of solids with a uniform cross-section. Default formula is volume is area of base times the perpendicular height of the object. The height is the one, again, as I said, perpendicular. It has to be perpendicular to the cross-section. So I'll explain what uniform cross-section means and what perpendicular means. So uniform cross-section is talking about, well, how do you slice the 3D object so that every slice looks exactly the same shape? So for example, if I've got this trapezoidal prism, right, this 3D shape, if I decide to chop it vertically downwards like this, will my slices look the same every time? Well, no, because these slices will be thinner on the edge, because they're just like the edge part of it, whereas on the middle side you'll get a wider, more area slice of your, if this was a cake, right, which is not the same, so it's not uniform. So in contrast, if I sliced this cake horizontally like that, then every single slice will look like a trapezium, and every single slice will have the same area of that cross section. And that's what we mean by uniform cross section. So the area of base, so the A here, the formula depends on the cross section area, which you're trying to cut the piece of cake so that every slice of cake looks exactly the same shape and has the same area. And the perpendicular height is then the height right angle to the cross section area of which you chop your cake into slices.